everyone. We're going to start a new topic called probability. Now, probability is a topic that you probably think about a lot without knowing it necessarily. So, for example, why do you drive on the right side of the correct side of the road? It's because the chance of you crashing if you drive on the wrong side of the road is way too high. So, you'll drive on the right side of the road. The probability is the likelihood of the chance of something happening. Probability is relevant to game shows. The chances of you getting on the game show, and then the chances of you winning money if you choose a particular option. The choice of whether to go to the casino or not depends on probability. If you do your research, you'll hopefully conclude the reality is that the chance of you winning money in the long run is very low, and there's a much higher chance of you losing money in the long run. But you need probability to understand that. It's relevant to if you're playing or watching sport. It's even relevant in day-to-day life, for example, insurance companies. So if you pay an insurance company money every year, a car insurance company, they will pay to fix the car that you crash into, and maybe even your car if you crash. Now, that sounds like a good deal if you want to minimize the risk of losing a lot of money in a crash. But the thing is, they have to decide how much to charge you every year, and they use probability to do that. They have to think about how likely is it that you are going to crash, and if it's more likely that you're going to crash, then you have to pay them more every year. All right. So where are we going in this particular video? We're going to learn a whole heap of keywords, and we're eventually going to get to the stage where we fill out this table, but importantly, we know these two terms: experimental probability and theoretical probability. So we're kind of building up to that. But we're going to start pretty basic. By the way, we're learning this because even though you'll know some simple probability questions like, what's the probability of rolling a 5 on the dice? That's going to be 1 out of 6 because there's 6 numbers on the dice. And you might know that, but you won't necessarily know the more complicated questions or how to answer them. So let's start from the start, which is a trial. A trial is a process which could have at least 2 different results. For example, if you flip a coin 3 times in a row, that has a number of results. It's a trial and it has a number of results. And actually all the results are here, but we'll get to that later. So this is head, you get a head, then a head, then a head. By the way, in case you haven't even seen a coin because you've paid with card your whole life, here's a coin. Look at that. Old-fashioned, beautiful. It's heads on one side and tails on the other side. Brilliant. All right. So a trial is the process of flipping the coin 3 times in a row. An outcome is a possible result of the trial. So one possible result is that you get heads, then tails. The sample space is a list of all the possible results, all of the outcomes. And here they are. There's 8 of them in this particular trial. An event is a group of outcomes called the successful outcomes. This word successful is kind of confusing. It doesn't mean that it's good to get this group of outcomes. It just means it's just a technical word for the outcomes in the event. So we could say an event is 2 of the coin flips are heads. So that will be exactly 2. So that will be this one. Oh, my computer's really not liking this. I'm not going to circle things. It turns out I can't circle things. All right, I can. This one. For goodness sake. All right. you get the picture. The event is a group of outcomes, and the outcomes in that group are called successful outcomes. All right, the probability of an event occurring, for example, the probability that 2 of the coin flips are heads, you write that PR and then in brackets whatever the event is. So for example, PR, 2 coin flips are heads. And now we're going to work out how to find the probability of this event. And that's called a theoretical probability. But before that, we're going to actually flip the coin 3 times. See if you can write down a guess for the outcome. So that will be one of these outcomes in the sample space. And we'll flip it. So it's tails, heads, heads. So tails, heads, heads. Which one's that? That is this one. Okay, if you guess that, well, the probability is actually 1 out of 8 because these are all just as likely as each other, all of these outcomes. All right, so, but how did I get that 1 over 8 exactly? Well, okay, it's this thing called theoretical probability. It's based on knowledge of a situation. So I know that all of these outcomes are equally likely. I know it's just as likely that I get heads, heads, heads as it is that I get heads, heads, tails. Now we'll learn about why exactly that is later on, but just a simpler example is I know it's just as likely that I get, if I flip the coin once, getting tails is just as likely as getting heads. So that's a simpler example. Okay, and by the way, all these, both the types of probability that we're learning, they both have the same formula, which is the number of successful outcomes, or the number of outcomes in the event, divided by the total number of outcomes. So the probability of getting 3 heads when flipping a coin 3 times is the number of successful outcomes in the event. I might do the probability of getting 2 heads because that's actually got more than one outcome. So that might be a more useful example for us all. The probability of getting 2 heads. Now, how many successful outcomes are there in that event? Well, this is the event. 2 of the coin flips are heads, and we saw that there's actually 3 outcomes. So the probability is going to be the number of successful outcomes, which is 3, over the total number of outcomes, which is 8. Okay. Oops. I'm trying to write P and R at the same time. Doesn't work like that. Okay. So that is theoretical probability. It's based on knowledge of a situation and equally likely outcomes. Experimental probability is different. It uses information about past events to predict what's going to happen in the future. So this is like an experiment. So one example is the probability of it raining tomorrow if it has rained 5 days in the last 2 weeks. So what could this look like? What are the successful outcomes here? And how many outcomes are there in total? So you're actually looking at the past outcomes in this one. So the probability for the future is based on the number of successful outcomes in the past. So how many is that? Well, there's 5. Now, this is where we get to the idea of successful, because you might not think it's very successful that it rains, but that doesn't matter. Successful outcomes are just the outcomes in the event that we're looking at. So we're looking at the event of it raining, and there's 5 outcomes in that event. So there's 5 outcomes. Now it says in the last 2 weeks. Does that mean on the bottom it's 2? No. We're talking about days here. So how many days are there in 2 weeks? There's 14 days. So the number of successful outcomes is 5, and the total number of outcomes is 14. Because each day there's an outcome. Each day it's either rained or it's not rained, and they're the outcomes. So the probability of it raining in the future is 5 over 14. Now, you might be thinking, is this really a good way of predicting the future? And my answer is it's not the best. But with weather, it's kind of hard sometimes because it can be so complex and unpredictable. I could say more about this, but I probably won't. I'm just going to say that it's not always a very reliable way of predicting the future, but in this case, it's the best you've got with the information that you've got. Okay, now finally, I'll skip that slide. We've got our last two definitions. Experimental probability is also called relative frequency. So you've got the formula here and an example, the example we used. And also theoretical probability based on theory or knowledge, the formula, same formula, and the example that we used. All right, now what I think you should do is copy this down because this is very important, and over the coming videos, we're going to be using these terms a lot. So you really need to take the time. Copying down is a really good way of absorbing the information into your brain. So because you're taking the time and focusing on it. All right, see you soon.